Hi, everyone, and welcome to today's episode of the Plumbers of Data Science podcast. Today is a session where I have a guest. It's usually I talk by myself, but today I have a guest. Amit Chain is here. Amit recently did a course for my academy at learndataengineering.com. And we talked about which course we should do because Amit is a data science specialist. He's a director of data science, and he said a Python course would be cool. And I also thought like Python, that's the thing that is needed, and where I also see the trends in data engineering. So I said, Amit, that would be really cool to do this course. We talked before. We talked that was last summer. Amit joined in our coaching sessions and gave a overview of Python for our academy students. So, yeah, welcome, Amit. Great to have you here.
Thanks, Andre. It's great to be on the show.
Do you want to give a quick introduction of yourself? That would be
Sure.
really cool.
Okay, great. Hello, everyone. Thanks, Andre, for inviting me on this show. Uh, my current role is I'm a director of machine learning with um, a startup based out of Kitchener Waterloo area, which is the upcoming tech hub of Toronto, Canada. And my overall goal is to build scalable data pipelines and machine learning pipelines that can serve the end customers of the company. And to that extent, we use extensive Python day to day, extensive data pipelines and machine learning pipelines. Uh, some of the work is experimental in nature, and some of the work is catered to the customer. So we actually deploy models on the customer site as well. Uh, this is a brief thing. I have overall 15 years of experience in the software industry, um, out of which last 5 years or so I have transitioned more to data science, machine learning, data engineering side of things. Right. Um, so any specific thing anyone would like to ask, I'd be happy to answer it.
Okay, thanks. Yeah. So for you, it's very Python heavy, right? So it's not like you guys are doing a lot of Java or a lot of whatever C++ or so, right? It's the main stuff for you is Python as well.
Yes, yes.
So are you when you designed the course on the site here? I can let me quickly show the course here. Basically
Yeah,
where we put the course, we have our academy on learndataengineering.com,
yeah,
where basically we have two things. We have the coaching that I do, the personal coaching, and we have the academy with data engineering courses. And for that, actually, Amit created the introduction to Python course, and build or
yeah,
put
yeah,
there the stuff that you thought that
yeah.
was important. So
Yes.
can you give some background why you think this is a good introduction for a beginner?
So I think I'll take a step back. Um, in my days of early college, um, I pretty much started learning basic language a long time back, and then my first brush with real language was C, and I still remember writing C++ programs. It was pretty crazy to figure out what's happening in the code when it crashes. What is a sig serve, what is SIGINT issues when the code crashes, right? And to write one line of or couple of lines of basic code in C, C++, or to that extent in Java for a beginner is not easy, right? And Python comes in, it fills a void where you have some um, idea in on logic, right? Programming is most of the times logic, right?
Yeah.
You want to express logic, but you get entangled in syntax of the language. So Python comes in where the syntax is very simple, right? And you express it. So I thought, from my experience, if I have to do a introduction to Python, right, and introduction to programming, how it will be very concise, uh, a course, very crisp course, very concise, just working on the very specifics of the language to get it going. You cannot learn a language in a year also, right? It's a
Mm.
big activity, but this is more of a, baby steps. Okay, at least it gives you some high level understanding of what language is, very basic primitives, and you will feel bit confident. Okay, oh, so Python is that simple, right? So that was my
Yeah.
whole motive of creating the course.
Yeah.
um yeah.
And that people can start out actually with, like, then have it as a quick start, how
Yeah.
they can start building with this, right?
Yes. And there
That
are tons and tons of courses available. There are courses which are, there are books written on Python, right? But this is very crisp course just to get you going.
yeah. Yeah. I think we what we talked about, oops, the wrong screen. What we talked about in the that's what we talked about in the beginning is that in the end we add something like reading writing JSONs,
Yes,
reading writing CSV files,
yes,
so that students already get the idea of, okay, how can I actually work with
yes.
simple data
Simple. Yes,
options,
yes,
yeah,
yes.
and start with that.
Yeah.
I want, before we continue, I have a question here from uh, Kriparam. Um, Data engineering course, is that includes Python? Um, well, the academy, basically all the courses in the academy, it's like a big bundle where everything is in there. Also, Amit's course and courses that I created, and in the future from other creators. So that's basically where we're going. And also the as you said, the AWS course has Python knowledge because we're working with Lambda functions, and
Oh yeah.
um, that's where you also see Python, right?
Oh
That's
yeah. Python is, I think, everywhere. Uh, if you want to start programming, I think Python is the language to start. And of course, you can, learn more languages, more frameworks later on the line.
yeah,
But Python is a good language to start, I'll say.
yeah, that's true, right? Because that also ties a bit into Kate's question here, where do you see Python 3 to 5 years from now? Like when I also have the data engineering cookbook, and I started writing this, I think 3 years ago now. And at that time, I'm coming from the Java world, so I'm not I didn't
Mm-hmm.
start with Python. I'm coming from the Java and C++, let's say the traditional work, the
Yeah, yeah.
traditional field, right? And we've been doing a lot of Java work in the past, and also when you think about Spark, you've done a lot of Scala work. But like in the recent, let's say, 2 years, there was a really a shift to everything in Python.
Oh yeah.
For Spark, everything went from Scala to Python. The Python API really got big. All the tools, wherever you look, everything is in Python. If it's on
Yeah,
AWS or on GCP, on Azure, you
yeah.
always find a Python API.
Yeah, I think the inflection point for Python came with the rise of machine learning. So machine learning, data science, and Python, they kind of played hand in hand with each other's success. And I'm seeing this. So if you see any framework, it has a Python binding, uh, TensorFlow, or even on the Spark side, right?
Yeah,
Everything has a Python binding on it. So I kind of see languages and frameworks into different problems they're trying to solve. So Kate asked, like, 3 to 5 years from now, Python, where do I see Python? I think I see Python gaining more and more. uh, acceptance in the ecosystem. Wherever machine learning, data engineering, wherever there is data, right,
Mm.
you are going to have Python, whether it is on the prototyping side of things or whether it is on the production side of things, right? uh, Python is gonna continue playing a big role. Other languages, other frameworks are gonna come for sure,
Yep.
but Python is going to stay. And if you see C++ are like 40 years old languages, they still have a big role in deep learning libraries. All the low level libraries are written in C++, right?
Yeah.
So I think Python is gonna stay for a while.
Yeah, that's true. That's true. I think it's also like Ravid has a nice point. By the way, Ravid wrote a comment before. Very nice to see us. Yeah,
Oh,
nice to see you,
nice.
Ravid. I
Hey.
think you also talked to Ravid before, right?
Oh, yeah, 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 yeah.
Yeah. Great to have
Nice.
you back, Ravid. Ravid had some problems on his LinkedIn account this
Uh,
week or over the weekend. Really annoying.
mhm.
Fortunately, it all has been fixed. But Ravid, talking about data engineering is trending heavily
Mhm.
as a career. Is there a roadmap? But generally, data engineering is trending, and also Python is coming because um, uh, when you think about, as you said, data scientists or Python got big with data scientists or data science in general. Data scientists also in smaller companies or at startup level, they need to do a bit of data engineering. They need to
Oh,
also
yes,
use these
yes,
tools,
yes.
and that's why there is this influence from data science into the actual engineering part, because in smaller projects they need to do both. And if you already know Python and have the libraries at hand, um, it's easy to get into. Like we've been looking a bit into this week into AWS and the actual libraries for AWS. And there's also like you can read data and you write it into pandas data frame and then use that. And for a data scientist knows what to do with it. It's like, I'm guessing it's the
Yeah.
daily use, right?
No, yeah, I think data science as a career is a broader field, right? It's a very broad field. And data engineering is kind of tied or hand in hand with entire ecosystem, right?
Yeah.
You cannot have a data science career without a data engineering, career, right? And most of the time, a lot of the work is into cleaning of the data, right? So one aspect of data engineering is where you build pipelines for data ingestion, pre-processing, and cleaning. And on
That's
the
right.
other end, you use that data to build models, right? So these are parallel tracks, and these are good career options, and they are growing for sure.
Yeah, yeah. As you said, it's a good point. They're going hand in hand. Like a few months ago, I was really always saying, okay, data engineering is a part of data science. Like it's like under the data science umbrella. I, from my point of view, it has changed a bit. Yes, but it's more like these two professions that are, as I said, they have some crossover, they have some touch
Yeah, yeah,
points,
yeah.
but you could also use data engineering without actually doing machine learning or without actually
Yes,
doing data
yes,
science, right?
yes,
So these
yes,
are
yes.
these are two. But for doing data science, you need some engineering, and that's also
Yes.
why data engineering right now is starting to come up in companies, because companies realize, okay, just by doing a proof of concept and having a data scientist to build stuff, somehow we need to automate this. Somehow we need to
Yeah, yeah.
bring this into.
Yes, yes. And that's a fair point because um, as companies grow, they have data, right? And
Hmm,
if they do not figure out a way to use that data, they're going to miss a lot of business opportunities, right?
that's
And
true.
that's where the data engineering is going to help them a lot.
Yeah, yeah, that's true. Because very often you see that there are some operational databases or operational systems, but the actual analytics for it is laughable. Like the
Hmm.
business insight into the data, that's where a lot can be gained, and even with simple steps. And that's
Hmm.
yeah, that's what people are working all around. I have that was a question here. That's a good question for you, Amit. What Python packages do you find yourself using the most for
Uh,
data science?
nice. This is a good one. Um, so scikit-learn is one of the all-time heavily used packages. People who start using data science in Python. Uh, that's the clear favorite one. And then NumPy, Pandas, SciPy, Matplotlib, um, Keras, PyTorch. Effectively, this is what maybe list of 10, 15 tools. These
Mm,
are like primarily used a lot, but I think one of my personal favorite is scikit-learn. I really like the way it is designed, and I go back to it um, really often to look at how they design the code, how they structure the unit test cases around estimators and other stuff.
mm,
This is on the data science machine learning part of things. Uh, and on, I think, data engineering, we have the PySpark as one of the very efficient written codes, which is being heavily used as well.
yeah. Where do you see Keras? Because a lot of people use Keras now, and like because
So,
it has a lot of straight out of the box
oh yeah,
functionality,
yeah,
right?
yeah. So I see it as a democratization of AI, um, because if you have to do, let's say, a image classification algorithm or a problem, you don't have the capacity or resources to train on huge data sets, like hundreds of gigabits of data set, right? So all you want to do is use a pre-trained model which is available in Keras, do some transfer learning and build a prototype. And if things go well, then you can start focusing on training the entire network at your end. So Keras as a framework is very well written. It has a very good documentation, and if you really need to squeeze performance, then you can look at PyTorch, compare it with Keras, right? Because
Mm,
there are purists um, of both PyTorch and for Keras as well, right? So I'm not going into, it's like a Vim versus Emacs type of debate which has been raging for ages now, right? So I like Keras, the way it is written, the way it is documented. Uh, I'm not saying PyTorch is good or bad, but if you are comfortable with PyTorch, use it. If you're comfortable with Keras, use it. But it's a
yeah,
good software or a good package.
yeah, that's true. Very good explanation. Like use what you like and what you're good at. That's also something I saw here. Where was that question here? In a different area, like here from another Amit, I can see a combination of Azure Data
Yes,
Engineering and Azure
yes,
Databricks
yes,
with Power BI. Great
yes.
opportunity. Like and that's these are like if you're in the Azure field or in the
Yeah,
Azure
yeah.
lane and you work with Azure, and then of course these are the things to actually look into and to go deeper in, and building pipelines using Databricks on Azure, having basically everything from Microsoft can be a really good thing, and use what you like, and yeah, so Databricks in general, Azure in general, very good.
Yes, yes. It is,
Yeah.
it is. And I think, I'll add to that is, um, so you have a cloud aspect of it, and then you have a conceptual understanding of it, right? And if you keep jumping from one company to other over a period of time, every company has its own set of tools, right? So,
Hmm.
but you should have a fundamental understanding of what the problem is and how you're trying to solve,
That's true.
right? And
That's
and
true.
these are just the tools.
Yeah, it's. I think for that would be a question for you. Is it's this? It's like in data science or for the data science, most likely ask for the engineer, because for us engineers is like if you're on AWS, you see the same stuff as you see on Azure. It's named a bit differently, but generally it works the same. Same on Google Cloud. Same if you're still in a Hadoop environment. So I'm guessing that, and that's what you already hinted a bit. It's the same in for the data scientists, that the different companies they use different tools, but it's like right.
It's,
You
yeah,
just
yeah. I mean, in the end, it is math and statistics, right? It's just what library you're using to build your model, right?
mm,
If you know what neural network is, all you and what different layers are, what back propagation is, um, you know. So these are the typical things in a neural network. All Keras or PyTorch gives you, or let's say other frameworks, is just how to build it, right? You don't want to build everything, like you don't want to build a neural network from scratch, like, uh,
That's true.
it it's they give you classes and stitch together lots of things and you build your
But
network.
but for you, but you also have to know how it actually works, right? Just
Yeah,
using the
yeah.
libraries is like, it's always
So
because there are people who are like just using the libraries but don't 100% understand. Like,
of course, I think you need to know to some extent, because if it crashes, how will you debug it? You need to understand whether this is the right uh, uh, let's say if you're building a network, right? If it's a regression problem, are you using the correct loss function? If it's a classification problem, are you using the right metrics to track uh, the precision or the recall or whatever metrics you have, right?
mm,
If you don't understand that and you fit a loss function which is meant for regression to a classification, then you are doing all wrong. You need to go back and at least get some basics right.
yeah,
So
yeah, get the basics right. Yeah, that's
yeah, yeah,
it sounds always so simple, but like I have the feeling that a lot of people start there's this I always remember there is this meme where you have that kid that has these steps, and it basically takes five at a time,
uh,
and that's sometimes people tend to do this. Yeah. um Let me look if there is another interesting. I think this could also be one for you.
uh,
How do you see
awesome.
ML up scaling up?
Oh,
We would have
awesome.
some parts
Oh, these are
pertaining.
these are these are really interesting questions. So
Yeah.
I think I have been fortunate enough to be part of ML ops for last couple of years now. When I started, it was not called ML ops per se. It was called machine learning in production, but I think it's ML ops is getting that new terminology, right?
Mm,
And what the overall industry has is slowly recognizing is taking machine learning to research, whether so it starts from data engineering to model deployment, right? I see it as end to end. So taking a machine learning from research to production is hard, and there are a lot of aspects to it: automation, reproducibility, uh, tracking how your models are behaving over a period of time, right? So most of these concepts are kind of um, captured into the ML ops scenario, and this is of late picking up a lot of steam, and a lot of companies are actively looking into it, and
yeah.
it is going to be quite critical to the success of machine learning.
Yeah, I see that as well. Like you have to have the right systems and the right, how do you say this, and the right processes in place to actually make this work.
Oh
It's
yeah,
not like taking a Jupyter notebook and automating this. That's not
yeah.
how it works.
That's
So
not
and
how it works.
yeah, and there are a lot of moving parts, as you said,
Oh, there are.
from a configuration level until the monitoring level. uh,
Yeah,
That and that's where I also see the engineering part of it, like giving the data scientists the tools to actually make this run in production,
yeah,
building up a monitoring solution, building up
yes,
a solution to manage configurations, building up a solution for the right storages, and so on. So
yeah,
or actually where to run it, like
yes,
keeping a Kubernetes cluster, or like giving the options
yeah,
to
yeah,
running Docker
yeah,
containers. That's like,
yes, yeah. And I think if the data scientists are a bit aware of the infrastructure, I don't expect them to be experts of that. They are better experts in data science and analysis field. But
yeah,
if they get some understanding of how the infrastructure can help them in the models, right? That is worth the effort.
yeah,
Um,
it's true. It's true. It's also the point is, And I had a few data scientists in my coaching
Mhm.
sessions. I also have a few data scientists in the academy. The thing is, at some point when you go and when you reach this point where your project, your company is uh, is in need of ML ops, of automating everything, then you need to understand the language of the engineer. As you
Oh,
said,
yes.
you don't need to have everything in detail, but you need to be able to understand what is the engineer talking about,
Yeah.
and maybe come up with a solution together that fits
Yes.
both
Yes.
yeah, both parties. So
Yes. Yes.
that's why I personally see also the scientist, very important for the scientist to have some engineering knowledge and understand
Yes. Yes.
the tools, the pipelines a bit.
Yeah.
You don't need to build everything, and but be able to.
Yeah. And to give you some personal experience, in my last one of my last roles, I was managing a software machine learning team as well as a data science team. And what I realized is the more they collaborated together, they discussed together, the more value it brought to the end product, uh,
Mm.
rather than working in silos. When they started working together, I could see a real quality product churning out day after day.
Yeah, that's true. That's true. The collaboration is very, very important. For you need to have these roles. You need to have, if you have both roles, the engineer and the scientist. These both need to be the people from each field need to be in line, like that the data scientist focus on the data science,
Yeah.
the
Yeah.
engineer focus on the engineering, but the collaboration is, as I said, is
Yes.
very, very
Yes.
important, and
Yes. Yes.
that's what makes it work. Otherwise, yeah. But about the collaboration, um, what I have seen and what I've been struggling since the last year, I've been struggling with a bit yeah, with the remote work. Before you were in a office and
Oh,
you
yeah. Yeah.
just talked
Yeah. Yeah.
about stuff.
Yeah.
Um, I don't know how it's for you, but uh, I find it very difficult to actually keep everything in line, keep people talking to each other, and like.
Yeah. I think I've been working from home for more than 13 months now.
Hmm,
It's one
that's
year is
amazing.
completed, and now I'm going beyond that. I kind of have a same feeling that sometimes you miss the face-to-face collaboration, and the Zoom fatigue comes into picture after a lot of time, right? But we have done couple of things. Like couple of things is trying to have uh, focused meetings, rather than having a general chit chat. Do some focused meetings,
Hmm.
as well as trying to set some agendas of the meetings, and try to organize our day in such a way that first half of the meeting is first of the days on meetings, and second half can be focused work. And also try to have office hours, like 9 to 3 or 10 to 3 are core
Hmm.
hours where you can ping anyone anytime.
Yeah.
You can call anyone anytime. The phone numbers are shared. Uh, so it's kind of, we have to work within the constraints of the pandemic. But this is couple of changes here and there are good. And sometimes we have, like, sometimes I'm having meetings and kids run over, and my team is okay with that.
Yeah, I have that as
So
well.
yeah. So even though there are things which we are missing, but I think we are seeing a different side of
That's
collaboration, right?
Yeah, that's true. That's true. It's sometimes it has its negatives. It also has its positives. That
Oh, yes.
when
Yes.
when you're working on something, and you can actually make sure that you're not disturbed. Like there's
Mhm.
no one going to show up right beside you and ask you something. Like maybe they write you on Teams something, but if you're really into a project or into work, then you can, let's say, blend this out. Like, okay, I need to focus on that. That's also a plus. And yes, I also have been doing team meetings with my team where Yeah, where I was basically sitting with my youngest here at the lab
Mm-hmm.
because
Yeah,
I
yeah.
need to take care.
Oh yeah, yeah.
Yeah. Let's see. Are there any more interesting questions? I think Amit, did we have some things? I think we talked a bit about full stack or machine
Mm-hmm.
learning data engineering roles. Like,
So
do we
uh,
want to
uh,
go a bit deeper into that?
let me give like some overview of it. So it is some kind of my thought process of how do I see a machine learning or a data science or a data engineer. These are all tied roles together, right? If you want to do just data engineering, that's a great option. If you just want to do data scientist, that's great, or ML engineering, right? But
Okay.
there is another concept where a person who can work across the cycle, right, from the in getting the data, cleaning it up, creating the data pipelines, can work on machine learning, model building, deployment, and can also work on data science, model generation. Uh, and it's more of a generalist, right? But you don't expect this person to be knowing each and everything, but he or she can, collaborate with multiple people on the team and
Mm,
understand each other's problem and um, communicate well across teams, right? So this type of roles are also important, so that the teams are not built siloed. They are not working in silos, right? So a full stack machine learning engineer, or can work entire end to end. And people, I have worked with few folks, and people really value their collaboration and their efforts,
mm,
right? And it also gives them a sense of choices. You have three options to look at, whether
yeah.
data engineering works for you, machine learning works for you, or data science works for you, right?
Yeah.
So
Yeah. But I think the machine learning engineer is an interesting part, like in between.
it's in between. Yes,
It's in
yes,
between. Um, I have to say I'm always a bit hesitant. Like I'm more I'm personally more of like a black and white
yeah, yeah, yeah.
like either data scientist or data engineer. But I think there are some good uses for machine learning engineers, but also uh, for the raw data, let's say raw data engineer, um, the same way as I explained before with the data scientist,
Yeah,
that the data
yeah.
scientist needs to understand engineering, the engineer needs to reasonably understand what is the scientist
Yes,
actually doing,
yes,
and
yes,
how is he operating, with
yes,
which tools. You, I always say for myself, I'm not a data scientist. I can't do machine learning. I can't program stuff. Like I can't code it. I can't make it work, but I understand like what does the data scientist do, and
yes,
what does he need,
yes,
and in
yes,
general how does the process work, and what
yes.
to expect. And I think that's very that's where what these both roles have in common, um, that they need to know.
Yeah. I think
Yeah.
the other thing I've realized in the industry, these terms are all over the place. People hire for machine learning, and the person is doing data science role. The role is a data science, and they're doing machine learning, right? So a data science is more of a research focused role, I'll say, whereas a machine learning role is more of focused on uh, deployments, productionizing things,
Mm,
understanding, being the bridge between the research and production. So
yeah.
needs to understand software engineering, needs to understand some part of the data analysis, data science side of things,
Yeah.
right?
But
So
that's where I also see where the machine learning engineer is more the
yes,
fitting role. Like the data
yes,
scientist
yes,
is doing, as you said, is doing the research,
yes,
is
yes,
actually figuring out with the algorithms and the data have a good solution. The machine learning engineer is working on actually the automation of this,
yes, yes,
and
yes,
but the machine learning engineer is not actually creating the algorithms and working on new algorithms
yes.
most of
Most
the
of
time.
the times, yes,
Yeah.
but nothing stops. Depends on the company to company
Yeah.
or interest
Totally.
to interest, right?
Yep.
And I see um, people who have software engineering background, they are more into the machine learning space. They do a transition from software engineering to data science via machine learning
Mm,
uh, road, right? And people who are primarily research oriented, like who have PhDs in different areas, right? It can be physics or
yep.
biology. They who have the domain expertise, right? They end up in the research side of data science things.
That's true. Yeah. Yeah. And to that, the engineering part, I see more people that are also, they know software development, software engineering, but they're coming more of the from the, let's say, computer science
Yeah.
part,
Hmm.
actually, from working with databases, working
Yes.
with yeah, with processing, working with
Yeah.
APIs
Like
and so
yeah,
on.
yeah, yeah,
Right.
yeah. Backend systems. Yeah.
Yeah, yeah, with exactly with backend stuff. Right. Yeah. Um, there's another question for us. No, let's go to this. I think that with the algorithms and stuff. If you have a large data set, what is the best to use Keras TensorFlow or PyTorch? I heard that Keras doesn't work well with huge amounts of data. Is that true? Can
So
you give some
uh,
insight on that?
so first of all, huge data set is you know I don't know what is huge. It can be exabytes, petabytes, terabytes, right? Um, there are problems which can be tackled by that with huge data sets. And I haven't got a chance to work on which is like 10 to power 21 types of data, which is really huge, right? But to begin with, um, rather than choosing Keras over PyTorch and worry about the large data sets, I think if you understand what neural network is trying to do with this data set, right? Uh, do you have understanding of whether GPUs will be required? Do you have an understanding of distributed computing on that, right? Then you can figure out Keras or PyTorch, right? And if you know one library, it's a couple of days of work to know other libraries. So
Mm,
if you're comfortable with Keras, try it out, see if it works out for you. If it does not work, then you can always switch to PyTorch. It depends on how what's the size of the project you're looking at. It can be a basic image classification problem, right? And it can have huge data set. Or sometimes you don't need it because you can just do transfer learning on it, right?
mm,
So there is no yes or no answer. It depends on your situation. If you're comfortable with Keras, do it and see what's the performance you're getting. If you want more performance, maybe use GPUs and then use PyTorch and then
yeah.
see from for yourself. But overall, I have seen from a lot of comments from people that yeah, PyTorch is better in terms of performance. But do you really need that performance? Is that your use case, or are you okay? Does 10 microsecond matter for you? Is
Yeah.
that the question?
Yeah.
If
That's
it
true.
matters, then yeah, go ahead. And anyways, when you build a product, you will have to do a lot of load testing and performance testing. So but if you think you want to learn a framework, Keras has a lot of value, so as PyTorch.
Mm,
So if you're learning a framework, you can learn anything.
yeah. It's I find this interesting because like I said, it's always, it depends. There is no
There is
this one is
yeah,
better, this one is
yes,
worse.
it depends. And the I think the whole engineering is a trade-off. The whole field is a trade-off. You
Mm,
have to balance multiple things, right?
yeah, that's
There's
true.
there's never a straight answer.
Yeah, that's absolutely true.
Yes,
It's in engineering is the same
yes,
as with
yes,
the data science part.
yeah, exactly.
Yeah.
But what I think my on another answer would be to the person is don't worry about these things. Just learn something, do something, and I'll be happy if you face this problem 2 years down the line, which means you have understood a lot of things before you hit that problem, right?
Yeah.
So
Yeah. And then you start figuring out
yes,
a new
yes,
solution for this and look
yes,
into other
yes,
stuff.
yes,
That's
yes.
a good tip. Like start with something, and you're once you reach that boundary
Yep,
where it doesn't work anymore, so, yeah,
yep.
search for a solution. That's a good point. Um, RML Suyog asks, "Hi Suyog, um, we're Suyog and I we're currently talking about a course that
Uh-huh.
he's doing a course
Oh, yeah,
for
yeah.
the academy.
Mm-hmm.
Meaning, is the output consumption automated? What is preferred for ML or on-premise or cloud? I would tackle the last part here, ML or on-premise. I think basically you can do both. It's not like on-premise. It's impossible to do machine learning on-premise and in production. The the cloud has some upsides, like for when you think about scaling and having
Mm-hmm.
software as a service or
Yep,
serverless
yep.
tools. It's very good, but from my side, you can do both. Like
Oh, yeah, yeah. I think it also depends on the size of the company. If you are just a startup, you don't want to buy data centers, right?
that's
Cloud
true.
works for you. And I've worked with like Fortune 500 companies where they have the resources and the teams to take care of their own data centers. So
Yeah,
uh, it all again it's a trade-off, right? It's on-prem or cloud. It depends on which company we are talking about and do you
yeah,
have the resources. But
yeah.
I would say if you are doing a POC type of thing, starting with it, try something on the cloud. You don't have to worry about infrastructure to begin with or deployments to
That's true. That's true.
upgrading of your databases, right?
Yeah, go very very fast. Create
Yeah.
something because it's really, if you know what you're doing, you can set up
Yes.
something very
Yes.
quickly.
Yes. And I
Cool.
think on the other question, the ML automation and other stuff. So it varies from every company, every organization, because the fangs of the world, the Googles, Amazons, they have entire ML automation uh, in production, right?
Hmm.
But there are companies which don't have it. Most of the stuff is automated, right? So we have the um, automation in machine learning at both the spectrums. Some are fully automated, some are not automated at all, some are somewhere in the middle, right? But
Yeah.
over a period of time, it has to move to automation. Maybe next 5 years, maybe next 10 years, I don't know. But it is if we see software development two decades back, CI/CD was not talked about, unit test was not talked about, right? But now most of the software which is developed has CI/CD and unit testing as part of it. So same is going to happen with ML over a period of time.
Yeah. That's true. That's true. Um, I think we're going to take a few more questions, and then we're going to finish for today.
Okay, sure,
I mean,
no worries.
I think, or do you have before we go to the question? Do you have a topic? Do you think you should, or you want to bring up, especially that that we should add to this, or should we just go to the questions?
No, I think I'll just um, share a couple of tips with people who are
Cool.
either into the field or beginning or intermediate or advanced, right? Uh, think about yourself as a carpenter, right? You have a set of tools. Based on the problem, you use a big screw, small screw, a big hammer, small hammer, right? You do not use one hammer and one nail for all the problems, right? So if you think of yourself as a person who is trying to build something, Python, Java, Scala, VI, Emacs, Keras, PyTorch, whatever you name it, these are all tools. If uh, you would be surprised to know one of the systems I worked in machine learning in production, it was giving great results, was simple linear regression model. nothing fancy, simple linear regression model. And I, that's a tool, right, for us. And if it is solving the customer problem, great. Why do we need to bring a 100-layer network when a linear regression is doing the job, right?
That's true.
So if you know your tools to some extent, you know which one will be used in which problem, that's great. And don't get bogged down to, Scala is good, Java is good, Go is good, Julia is good, and there's so many is coming up. If you have the capacity and you have the team, learn it and then do it. Right? That's I think my thing has uh, been worked with C, C++, great languages. Uh, they do great stuff, right? On the other hand, we have JavaScript, another great language, right? So
Yeah.
every tool language is great. Just use it as needed.
Yeah, that's true. I think that's also something a great point. Like know your tools and what works works. Like because I we see this on the engineering side as well. Like people people go uh, for Spark. They're starting to look into Spark and want to do Spark, although it's not really necessary.
Yeah.
Like why or go with a fancy NoSQL database when a normal database, a
Yes.
normal relational also
Yes.
works.
Yes.
You need to know the tools so you can decide, is this, does that still work? Does that make sense? Or am I already go doing overkill?
Yeah. Yeah.
And you don't want to use something, you don't want to go the route where you use something when it's not really necessary.
Yeah.
That's
Yes. And
that's
and
yeah.
and lots of people in this field, whether data engineering to data science, are coming from non-CS, non-triple E backgrounds, right? And for them, I mean, if I ask someone to write some neural network in C++, right? How many of how many of us will be able to write it, right?
Mm.
And that's where Python is coming into picture to, uh, take off that load. The lot of heavy lifting is handled by these libraries,
Yeah,
right? Uh, we need to understand what our objective is. Do we want to learn the language or we want to build a product?
that's true. um Here's another question. What should be the exact
Mhm.
roadmap for learning cloud implementations over the data science field or any other similar type of field? Is Microsoft Azure certification needed in that case? Regarding the certifications,
Yeah,
like they are useful, um, but they for giving you the basics or for joining
yeah, yeah, yeah,
companies where it's needed, where they require this. But my view is always start with, you should do a project, even if you're a
yes,
student. Do a
yes,
project and don't rely on certifications,
yeah, yeah.
right?
I'm not sure how many of these students or people who are new into the field are aware that AWS, Azure, GCP, they offer free credits for 1 year or so.
Yeah,
So you can build small projects using that, and if you feel confident, then you can go for certifications. But certifications, they do cost money if you can afford it. Are they mandatory? I i don't think that should be the case.
yeah,
As an industry, we should value them, but we should not make them mandatory.
yeah. Yeah, it's like they take a lot of time
Yes.
to actually do, and very often they also go into a level, like from an educational level, where you don't really need it in your day to
Yes.
day.
Yes.
It's you could look this up on the internet as well,
Oh,
or
yes.
in the
Yes.
documentation, but they have everything in there to make sure the person who goes through the certification has heard about it and has tried to apply it.
Yes. Yes.
But like, yeah, you can do a lot outside
Yes.
of the whole thing, of the whole
it it
certification space.
it may help you in getting a door in the foot, sorry, a foot in the door,
Yeah.
but not every time. Maybe if you have good projects to show, that would be great.
Yeah. I'm trying to figure out another question here. That is not very because sometimes people write you very general questions. Maybe you can go at it. Like one question here was I learned all the data science algorithms. Can you provide me a roadmap for what to do
Oh,
next? Like these are very general and hard to
yeah,
like.
these are no. I think when you say that I have learned all the data science algos, I think you. I don't take that honestly. Learning all data science algos, I don't think that's a real statement, right?
Mm,
Um, there's so many algos in data science, right? Have you? And even if you have learned that, what have you done with that? It's like I've learned all the maths, right? That's fine, but now we go implement something, build a project. It's an image classification model, or build a recommendation system, or uh,
mm.
NLP, right? There's so many things which are coming up, right? Can you use your knowledge and build something? Like theory is always good, but can you put that into practice, right?
That's a good point. That's a really great point. So the roadmap would be actually try to implement this into
No,
somewhere,
I
right?
think with the data science being a very vast field, a roadmap for what? Are you looking to enter into data science for a job or a research, right? If because a roadmap has to be customized. If you're
Yep.
looking for a research role, then you have to identify which problem you would like to solve because you have to spend next 5 years on that, right? If you're looking for a job, then you don't need to be specific into one area. You can know bits and pieces of various data science verticals. Like you can build some recommendation system, you can build some regression models, right? So you can show the breadth and depth of your knowledge to the potential employers.
Mm.
Some might be working on image classification, right? So couple of projects here and there to catch an eye of an employer, that would be great.
Yeah, that's true. That's for I always recommend my students to like figure out which direction do you want to go, which
Yes,
industry do you want to go,
yes,
then use a data, do some research,
yes,
what are in the job descriptions, and take a data set that fits to these industry
yes,
to one of these
yeah,
industries and just do a project with it. Start actually applying the
yes,
stuff.
yes,
And
yes,
in your case, like it could be that when and I'm not sure who said it, like I learned all the algorithms. Start with applying one in
yes,
production in real
yes,
world, and then do the next and start building something.
yes,
Yeah,
yeah.
because John here has a really nice point. Experience matters more
Oh
than
yes,
certifications.
yes,
That's
yes,
absolutely true. It's absolutely true.
absolutely true. Yeah.
Yeah. Um. Yeah. Uh. The last question here. Here's the last from YouTube, and then we're going to go. Um. Here's Amit. Speaking of overkill these days, see people going for multi-layer complex models even for simple use cases. Could you
Yes.
give us a few examples of complex problems you have solved? Simple models.
Yep.
I mean,
Uh,
that's more a
yeah. I
question for
think
you.
yes, yes. This is really great. I think if you um, I think I told earlier also. So in one of my earlier roles, we were supposed to build a, a a regression model. I'm not sure if I can or it is confidential, but we were.
Mm.
I cannot give you the details of
Keep
it,
it
but
keep
it
it
is
general.
yeah. Okay. So we were basically trying to do a regression model for predicting price of a particular set of items. Let's say in my case the items were different, but let's say we're trying to build a housing price regression model, right? And when we say housing price, it is there are different use cases from a business perspective, right? Internal teams might need a different set of pricing to list some entities or some items on the website or the app. External teams or external customers might need a different price, right? So there are multiple use cases for a pricing prediction problem. Now in one of the use cases, we just wanted a initial price of the item before we could release it to the website. Like, this is the bottom price. The price cannot be lower than this. If I'm putting something on the market, this is my absolute minimum.
Yeah.
I cannot go beyond this, right? And if I go beyond this, I'm going to lose money. So I should not sell on, I should not even post it.
Yeah.
So that was a plain. We did couple of things, and we figured out that a linear regression uh, is quite accurate, and it's beating the other um, deep learning models to some extent. So we just stick with the linear regression model. We know there are 5, 6 features, and this is how it's going to work, and that's it. And it did well for a lot of time, like maybe a year or so, and that's a good time in the industry if a model is there for 6 to 1 years. Of course, we had to update it with a couple of more features here and there, but it was good. Another example was in the image uh, classification problem which we're trying to solve. Instead of using a huge network of 150 layers and other stuff, we built a very simple model. Uh, I think it was primarily a basic VGG2 model or something, which is bit um, less in terms of layers. It is still a neural network, but it is, I don't recollect on top of my head right now, but it is less complex than the state of the art models which are coming now, right? And it was working fine for us. It was able to detect the bounding boxes and other stuff for us. So we used it. So unless and until you get a problem, just don't go to deep neural networks right away.
Yeah.
Right? Analyze the data, see if basic models can work, and if they work, fine. And there are processes involved. You need to know what is your metrics. How do you know that this model is successful for you, right? If you know that, uh, sometimes you just need a basic model, or sometimes you just need a mean of that sample data set, right? So assuming your problem is that you need to figure out a mean uh, or median household income of this postal code and plot it by that, right? It's simple statistics, right?
Yeah.
So
Yeah.
knowing the problem in depth is more important to begin with, I'll say.
Yeah. That's a nice. I think that's a nice ending for this. Knowing the problem. That's the most important important thing.
Yeah,
That's
yeah.
very nice. Yeah. And that's so true. That's so true. Okay. I mean, we're going to finish here. Thanks for coming
Awesome.
by. Thanks for doing the course. Maybe we can figure out a follow-up course. Maybe for the engineer, some machine learning
Hmm.
basics or something. I think we can chat about this
Oh yeah, sure,
afterwards.
sure. No worries, no worries.
Um, for everyone, I'm sorry where we missed the comment. There were a lot of comments, and we would have gone like 2 hours with that. So sorry for not getting to every comment. This video is going to be is recorded here on LinkedIn. It's going to stay on LinkedIn. It's also available on my YouTube channel. Just search my name, Andreas Kretz, and you're going to find it. I think you also, if you search for Plumbers of Data Science, you can find my channel. This will also go on our website on learndataengineering.com. Basically on Amit's course, we put this video, and this will be on the podcast that you have, is the Plumbers of Data Science podcast on all major podcast stations, Apple, Spotify, Google, and whatever. Okay.
Awesome. Oh,
Thanks everyone.
thanks. Oh,
Thanks
thank you so
Amit.
much. Yep, thank you, everyone.
Have a great one.
Yep,
Bye
you
bye.
as well. Bye.
Bye.
See ya. Bye.
See you later.